Resistance capacitance, or RC coupled amplifiers, are so termed because the amplifier stages are coupled by combinations of resistances and capacitors. Advantages of RC coupled amplifiers are high fidelity over a wide range of frequencies, relatively high gain, low hum pickup from nearby AC fields, small space requirements, and low cost. The disadvantages of RC coupled amplifiers are higher B-plus supply voltage is required, and the reactance of the coupling capacitor increases at lower frequencies, thus reducing the gain. Now let's analyze a typical RC coupled pentode amplifier. In this schematic drawing, C1 is an input coupling capacitor from a previous stage. R1 is the grid return resistor which connects the grid to ground, or B-. It also develops the signal voltage for the tube. R2 is the cathode bias resistor, used to develop a voltage drop that can be used as bias for the tube. C2 is the cathode bypass capacitor, used here to filter out variations in the cathode current, thereby maintaining a constant drop across the cathode resistor. C4 is the screen bypass capacitor, which serves to remove any variation in screen current from the B-plus voltage and to bypass these variations to ground. R5 is used as a screen dropping resistor. Its value depends upon the potential at which the screen must operate. R3 is the plate load resistor for the tube. Its value depends on the function of this amplifier and the type of tube used. The larger the value of the load, the lower the voltage on the plate. C3 is the output coupling capacitor for the tube and the input to the following stage. R4 is the second stage grid resistor and performs the same function as resistor R1. The RC coupled amplifier, because of its better frequency response, is used in almost all types of amplifier circuits where broad bands of frequencies are utilized, whether they be audio, RF, or even some UHF. Now let's change the plate load resistor to an inductor, and we have an impedance-coupled, or LC, amplifier. LC amplifiers have one particular advantage. Removal of the plate load resistor reduces the voltage required from the power supply. However, LC amplifiers have a disadvantage. Due to the inductive reactance of the inductor at low frequencies, the gain is small. As the frequency is increased, the gain increases until the distributed capacitance of the circuit nullifies any further gain, and frequency response drops off. Therefore, around the middle of the audio frequency range, the LC amplifier will give maximum gain. Analysis of the circuit is essentially the same as for RC coupling. When it is desired to select one frequency out of the middle of the audio range, the inductor can be tuned by placing a capacitor across it. This makes the LC amplifier very selective. An amplifier circuit using transformers as coupling elements is called a transformer-coupled amplifier. This type may be used either as a voltage or power amplifier. When used as a voltage amplifier, transformer design can permit stepping up the voltage between amplifiers. One advantage of transformer coupling is that at lower frequencies, the step-up characteristics increase the voltage to a point where fewer amplifier stages are needed. When a transformer is used to couple between stages of amplification, it is called an interstage transformer. When the transformer is used in the final stage to couple the output to the device which will reproduce the sound, it is called an output transformer. Usually an output transformer has a step-down ratio because by reducing the output voltages, the current is increased to the larger values required by the load. It also serves to match the generally high impedance of the power amplifier to the commonly low impedance of the output device. Interstage transformer coupling is superior to other methods of interstage coupling in many respects. The step-up ratio permits the amplifier voltage gain to exceed the amplification factor of the tube. Transformer-coupled amplifiers can operate with a lower plate voltage. The circuit is readily adapted to push-pull operation. Transformer-coupled amplifiers have several disadvantages. The cost is greater, since the cost of transformers is considerably higher than RC coupling elements. Frequency response extends over a relatively narrow band and is less uniform than in other methods of coupling. Stray AC fields induce undesirable stray voltages into the transformer. Also, interstage transformer coupling requires an amplifier tube having a low plate resistance. To analyze the circuit, we can see that T1 and T2 are interstage transformers. T3 is an output transformer. When the microphone is energized, the very small voltage is stepped up through the interstage transformer and applied to the control grid of the first amplifier tube, V1. V1 is a standard pentode tube, with the plate voltage being applied from the B+ supply through transformer T2. The bias for the tube is developed by the cathode resistor R1 and held constant by the bypass capacitor C1. The input signal influences the current flow through the tube, and this current, passing through the primary of the interstage transformer T2, induces a stepped-up voltage into the secondary. The same action is repeated for V2. But the voltage across transformer T3 is stepped down. When voltage is stepped down, current is stepped up, resulting in small voltage but high current across the speaker. As you know, power is equal to the current squared times the resistance. Thus, sufficient power is obtained to produce sound of the required loudness. Notice that in the plate circuit of V2, there is a resistor R5 and a capacitor C4. These elements are placed in the circuit to decouple any variation in the B+ voltage around the power supply. This type of circuit is found when there is more than one stage operated from the same power supply. In many RF circuits, tuned transformer coupling is used between stages. This method of coupling has several advantages. For one, it makes the circuit very selective. Still another advantage of tuned transformer coupling is that the bandwidth may be broadened by adding resistance to lower the Q of the tuned circuit. In addition, the cost of the transformers is substantially reduced. This is because there is no need for the iron core and the number of turns required is less. Now let's analyze the typical tuned transformer coupled circuit. Pentode tube V1 is operated as a Class A amplifier. This is determined by the cathode resistance and the fact that there is a very low DC resistance in the grid-to-cathode path. That is the secondary of T1. There are two reasons for operating the stage in this manner. One is that the grid will be more sensitive to any voltage change. And two, the tuned transformer makes the stage very selective. The screen voltage is applied through resistor R2, which drops enough voltage to supply the correct amount to the screen. Bypass capacitor C6 bypasses any variations in the screen current. The plate voltage is applied through the primary of T2. Ganged tuning capacitors C1, C2, C3, and C4 make resonance circuits of T1 and T2. All these circuits may be resonant at the same frequency or at different frequencies. A pentode tube is used in this circuit to give maximum gain to the signal voltage, which arrives at the antenna in the microvolt range. The last method we will discuss is direct coupling. A direct coupled amplifier, DC amplifier, is a vacuum tube circuit whose coupling network consists of resistive elements and direct connections. The chief difference between this method and RC coupling is the direct connection between the plate of V1 and the grid of V2, which eliminates the coupling capacitor used in RC coupling. Direct coupled amplifiers have several advantages. One, it has excellent low-frequency response. Another advantage is that the response of DC amplifiers is the same for slow variations as it is for non-varying signals. And a direct coupled amplifier is suitable for amplifying both alternating and direct current signals. Chief disadvantage of DC amplifiers is that due to distributed capacity in the circuit, the response drops off in the high-frequency range. Direct coupled amplifier circuits are used chiefly in vacuum tube voltmeters, in oscilloscope deflection amplifiers, and in radio teletype circuits. To review some of the main points, a vacuum tube amplifier amplifies sound by increasing low-level energy to a higher level in an identical waveform, or as nearly identical as possible. There is a particular use and mode of operation for Class A amplifiers, Class B amplifiers, Class AB amplifiers, and Class C amplifiers. Amplifiers are also classified according to types of service, whether they are to be used as a voltage amplifier or a power amplifier. There are four general methods of interstage coupling. They are resistance-capacitance coupling, impedance coupling, transformer coupling, and direct coupling. It is important that you learn the theory and operation of basic amplifiers. That you know their classes and types, advantages, disadvantages, and use. That you become thoroughly familiar with methods of coupling and multi-stage operation. It is only by a thorough understanding of all this and more that you may become an expert in the increasingly vital field of electronic equipment repair.